briefly walk you through the molecular shapes lab, molecular modeling. So the first thing you want to do is open up the periodic table if you don't have one in front of you, and then you're going to look at the data sheet and draw all the Lewis structures and fill in all the blanks, and we'll go through all of those. And then you're going to hit this simulation and start building those molecules. So let's go to the data sheet first so you can see what I'm talking about. So the first thing you want to do is draw the Lewis structure for water. So I'm going to walk you through the water drawing. So to draw the Lewis structure of water, you need to count up the number of valence electrons. So I'm going to go to the periodic table. Hydrogen has 1 valence electron, and I have 2 hydrogens. And then oxygen has 6. I have 1, 2, 3, 4, 5, 6. Okay, so oxygen has 6. Oxygen has 6, and hydrogen has 1, but I have 2 of them. So that gives me a total of 8 valence electrons. I'm going to put oxygen in the middle. Hydrogen's over here. I just used up 4 electrons. I have 4 left over. I'm going to add 2 sets of lone pairs. So when I look at that, I can count up the number of electron domains. I have 1, 2, 3, 4 electron domains. So 4 electron domains means I am in the tetrahedral electron domain. I'm just going to make that red so I can see all my answers. The molecular geometry, so when I have 2 bonding orbitals and 2 non-bonding orbitals, this is bent. And all of this is in the procedure, so if you go, it is in the introduction. So if you look here, there's a nice little table, a lot of tables, there's a lot of tables here. So water would be in number of electron domains, I counted 4, and then I looked over here, I have 2 bonding, 2 non-bonding. So the electron domain geometry is tetrahedral, molecular is going to be bent. Oh, and I even listed water as an example there. Bond angles are roughly going to be 109.5. We're approximating, so we're saying everybody in tetrahedral is going to have 109.5. Okay. Then what do we do? So I would highlight 109.5 as the next answer. So you can circle that, or if you're doing this, electronically, you can just highlight it. And then hybridization. Hybridization has to do with how many electron domains I have. So if I go back to the introduction again, there's a little section on hybridization, and you can just look up the number of electron domains. So if I have 4 electron domains, I'm sp3 hybridized. Okay, so let's go back here and say that's sp3. Done. And then is this polar or non-polar? This is going to be a polar molecule. It's polar because of the shape of the molecule. This is bent. So these two, if you think about the bonds as being like forces, it's not linear, it's bent. So you're going to have a net pull in one direction. So after you answer all of these questions, and we're going to explore polarity again in part B. That's going to be a different video. So after you have answered these questions, now you want to go to the simulation, which I already clicked on. Here we go. Click on model, and now I'm going to model that. So I have 2 bonding domains. That's kind of the default. I'm going to add my 2 non-bonding domains. So this is what water looks like, this guy. You can see that it's bent there. Great. I can click molecular domain geometry and electron domain geometry, and it gives me, I can check my answers. So the electron domain geometry is tetrahedral and molecular is bent. That's true. You can also show the bond angles. So that's where the bond angle is right there. So you're going to do that for the rest of the molecules that we have on this table. Check your work. And that is part A. There's quite a few of them. Yes, there are. And then we'll talk about part B.